Hello everyone, welcome to the recorded lecture of plastic processes under the subject IE 206 Industrial Materials and Processes. So after discussing this lesson, you students must define what is plastic and their properties and classifications, explain the different types of plastic processes, discuss the working principle for each plastic processes, evaluate the advantages and disadvantages of each process, enumerate the different applications of plastic. So for the introduction, plastics are a wide range of synthetic or semi-synthetic materials that use polymers as main ingredient. When we say synthetic plastic materials, we are referring to those plastic materials that are entirely laboratory made. So examples are phenol formaldehyde and many polyplastics, or those plastics that we commonly see as packaging plastic materials when we go to the market. Those that we call as plastic bags. On the other hand, when we say semi-synthetic, those are plastic materials that are chemically altered naturally, meaning there is a little chemical added to them to be or to have the desired property of a plastic material. So the main difference is that semi-synthetic is comes with natural materials, while synthetic plastic materials are laboratory made materials. Okay, so for the plastic materials, the main property here is plasticity. Okay, because of this property, it is very useful in many applications. Okay, so we already discussed what is plasticity. Even other materials such as metals have the characteristic of plasticity, but not as much as plastic materials have. So this plasticity property enables plastics to be molded, extruded, or pressed into solid objects. So it becomes, or the plastic materials becomes adaptable to a wide range of properties such as lightweight, durable, flexible, inexpensive to produce, and has led to its widespread use. Okay, so plasticity allows molding, extrusion, or compression into a variety of shapes, such as films, fibers, plates, tubes, bottles, and boxes, among many others. So there are two types of plastic. First is the thermoplastic. So these are plastics that can be deformed easily upon heating and can be bent easily. Linear polymers and a combination of linear and cross-linked polymers come under thermoplastics. So due to the structure of these thermoplastic materials, which is with linear structure, they are easily shaped. So examples are PVC. So those PVC pipes are example of these thermoplastics. Nylon, okay, the nylon rope is an example of thermoplastic. Polythene. What is polythene? Polythene, also known as polyethylene, is one of the most commonly used plastic in the world. So polythenes or polyethylenes usually have a linear structure and are known to be addition to polymers, meaning they are or this material, polyethylene or polythene, is an additional material to many polymers to achieve desired properties of a plastic material. So the primary application of polythene or polyethylene is synthetic polymers that are used in packaging. Okay, The next is thermosetting. So these are plastics that cannot be softened again by heating once they are molded. So thermosetting plastics are the opposite of the thermoplastic. Thermoplastic. Okay, because thermoplastics are softer than thermosetting, or in other words, thermosetting plastics are harder than thermoplastic materials. Okay, so this is because thermosettings are heavily cross-linked polymers, come under the category of thermosetting plastics. So examples are bakelite, melamine. So what is bakelite? It is used for making electrical switches. So if you observe your electrical switches in your house, you can observe that they are brittle, okay, and they cannot be molded into another shape or to gain new dimensions after they are being heated because of their brittleness and hardness. So while the melamine is used for floor tiles, so this application is again can be found in our houses. Okay, we notice that the floor tiles are hard plastic materials. Okay. Next is the classifications and properties of plastic. So for the classification of plastics, it is based on different categories that are in accordance to the characteristics of plastic materials. So first category is by chemical structure of the polymer's backbone and side chains. So when we say polymer's backbone, under the polymer science, it is the polymer chain, or simply the backbone of a polymer. So that is the main chain of a polymer. So polymers are often classified according to the elements in the main chains. The character of the backbone is flexibility. It determines the properties of polymers. Okay, so the examples here are acrylics, silicones, halogenated plastics, polyesters, and polyurethanes. So these are the polymers backbones of these examples. So you will notice that they have similarities in their structure as well as in their components. So that's the first classification of plastic. Then number 2, by the chemical process used in their synthesis. Okay, like condensation, cross-linking, and polyaddition. So when we say condensation, it is twinned with polymerization. So it is a form of step growth polymerization where smaller molecules or monomers react with each other to form larger structural units. So usually polymers, while releasing byproducts such as water or methanol molecule. So the byproducts are normally referred as condensate. So it is a chemical process. So there are certain plastic materials that can be combined or fused through this condensation polymerization chemical process. Next is cross-linking. What is cross-linking? In chemistry and biology, a cross-link is a band or a short sequence of bands that links one polymer chain to another. So these links may take the form of covalent bonds or ionic bonds, and the polymers can be either synthetic polymers or natural polymers. So vulcanization is an example of cross-linking. So there are plastic materials that can be cross-linked, and there are plastic materials that cannot. Okay, so example is when we are vulcanizing the tires of our vehicles. Okay, so the rubber materials fuse together by the cross-linking chemical process. Next is polyaddition. So polyaddition, what is polyaddition? So it is also called as addition polymerization. So it is a polymerization, a reaction that forms polymers via individual dependent addition reactions. So it is synonymous or have the same process with condensation. It combines different polymers. Next is by their physical properties. So we already know these physical properties. Other materials such as metals also have these properties. So the hardness, plastic materials have hardness also, tensile strength, thermal resistance, glass transition temperature. What is glass tension temperature? It is the temperature at which an amorphous material, polymer materials turns into a viscous liquid or rubbery form temperature. So it is often abbreviated or is abbreviated by TG, glass transition temperature. So it can also be defined as the temperature at which an amorphous polymer develops the characteristic of glassy state properties such as brittleness, stiffness, and rigidity. Okay, upon cooling. So that's a physical property of plastic materials, as well as density. So that's the mass over volume of the plastic materials. Number 4, by the resistance and reactions to various substances and processes. First is oxidation. So oxidation of plastic materials are not it's not about the exposure of plastic materials to moisture, because we all know that plastic materials are not cannot be oxidized by moisture, but rather by other chemical solutions such as acidic chemical solutions. So ionizing radiation, so that is one of the process of chemical reactions. Okay, when chemical solutions are being exposed to plastic materials. Next is by the qualities relevant to manufacturing or product design for a particular purpose. So these examples depends on the usage of the plastic product that is being used. So first is thermoplastics that we already defined a while ago, conductive polymers. So polymers are insulators in nature, right? But conductive polymers have gained its conductivity properties by other additional materials. So this makes conductive polymers as a composite materials because it has added conductive materials in it. Then engineering plastics. So engineering plastics, these are usually hard plastics to support for engineering work such as in the construction, in the safety fields. Next, biodegradable plastics. So these are commonly the plastic bags that we use when we go to the market. Thermosets, elastomers. So elastomers, those are the adhesives or paints. Okay. Next, these are the general properties of plastic materials. First is plastic materials are strong and ductile. So plastic materials are often selected for applications that require toughness and impact resistance. Certain plastics such as ABS. So are you familiar with ABS plastics? Those plastic materials are very strong. They are used for aerospace, as well as the automotive or automobile industry, because ABS plastic materials are used for our cars, for the manufacture of cars, and as well as motorcycles, etc. Okay, they have the outstanding toughness. So those hard plastics, are frequently used for industrial, construction, and military applications because they are durable. Next is poor conductor of heat and electricity. So we all know that plastic materials are insulators. Okay, easily molded into different shapes and size because they are easily melted. Okay, by heat or thermal energy. Resist corrosion and are resistant to many chemicals. Okay, So these are the general properties of plastic. So next is the processes of plastic. So first is processes under the what we call as plastic forming. It is the use of the plasticity property of plastic materials under the external force of the tool in mold to process the workpiece with less or no cutting process. These are many types, so we will go by this one by one. So first is 3D printing. So 3D printing, also known as additive manufacturing. So it is called additive manufacturing because we are adding materials in doing such process, putting up materials together to make a whole product. So it's a method of creating a three-dimensional object by layer using a computer created design, creating less material wastage because 3D printing are often run by computer system. Next, 3D printing is also perfectly suited to the creation of complex bespoke items, making it ideal for rapid prototyping. So because 3D printing can make products with complex dimension, shapes, etc. So these are thermoplastics. The 3D printing materials uses thermoplastics, metals, resins, and ceramics. But our focus here is thermoplastics. Okay? So under 3D printing, there are three main types of processes. First is selective laser sintering, or SLS. So it is a 3D printing process that uses high-powered lasers to sinter or bind finely powdered material together into a solid structure. The material used here is a thermoplastic powder. Okay, so I will just send to you the link of the video for selective laser sintering, or SLS. So the thing that you have to remember under this kind of 3D printing is that it utilizes high-powered lasers, and it is used with a large 3D printer. Okay, larger than a portable 3D printer. Okay, so this process SLS cannot be done in portable way. Okay, because it requires large 3D printer, because it utilizes high-powered laser and it produces a high temperature because of the strong laser beam. So what is the working principle here? The laser selectively fuses powdered material by scanning cross-sections generated from a 3D digital description of the part on the surface of powder bed. Okay? Alright, so this process is connected with computer system. Okay, for it to detect, that makes it capable of detecting such 3D designs. So to continue the working principle, the powdered bed is lowered one layer thickness through the piston by moving downward. And again, the laser scan to another layer of the cross section. So it is the working principle is about scanning layer by layer of the powdered polymer plastic. Okay, that is called powdered bed. After scanning, the roller moves the right, applying new layer of material on top. Okay, so it keeps on adding layer of materials as it after it is scanned. Okay, the 3D shapes. Again, the laser scan another layer of the cross section. The roller moves again from the right to left, applying new layer of material on top. So the process is repeated until the part is completed. That's why it is under additive manufacturing, because it adds materials together, or it builds materials together to make a product or a part. Okay, so next. Okay, so this is the schematic diagram of selective laser sintering. So this is the laser and this is the roller. This is the scanner of the 3D printer. This is the powder bed. Okay, so the fabrication piston which goes up and down. So this is the powder delivery system. Okay, so that's the mechanism of selective laser sintering. So the system automatically selects the 3D design for it to form a part, and it keeps on building the part until it gains the desired specifications or dimensions. Okay, so you will learn more about this when you play or watch the video that I will forward to you. Second is stereolithography or SLA. So the first one is SLS. So this one is SLA. So the original industrial 3D printing process that uses a computer-controlled moving laser beam pre-programmed using CAD software. Okay, so this one is the commonly used 3D printing. Okay, so this one is can be done with portability, meaning SLA 3D printers are smaller than SLS. Okay, and these are programmed using your AutoCAD, okay, CAD software or CAM software. So the working principle here, again, I will just forward to you the video so that you can visualize about this process. Okay, but I'm just telling you the main difference of the SLA 3D printing to the other one, SLS. Okay, SLA is more on portability, okay, handy process, and do not produce high laser beam, but rather it utilizes UV light, okay, to fuse plastic materials. Okay, so this is the schematic diagram of SLA or stereolithography. So this is the laser generator, okay, which uses UV light. So this laser generator is not as strong as the one that is used in the SLS. Okay. Alright, so this is the part, okay, to be processed. So these are the resin tank, wherein the resin or the plastic materials are put, okay, in order to form a part. Okay. Next is FDM or fuse deposition modeling. So FDM, also known as the material extrusion additive manufacturing technique, utilizes polymers as the raw material or filament. The filament is usually heated to a molten state and then extruded through the nozzle of the machine, 3D printer. Okay, so this fuse deposition modeling or FDM is also a kind of 3D printing. Okay, so the working principle is all information about the product is loaded in the CAD software. So it is also run by a computer system. Okay, specifically the CAD software. So you will do the design in your CAD software, and then the system will forward the information to the 3D printer. The polymer raw material in filament form is heated to a molten state and extruded through the nozzle. Okay, so the pelletized plastic materials are being melted, okay, and are run through a nozzle. When you say a nozzle, it is like an opening, okay, an opening of the melted plastic materials. So the nozzle head deposits extruded polymer on the build plate layer by layer. Okay, so this is the schematic diagram. of diffuse deposition modeling, or FDM. So this is the nozzle, and it deposits the melted plastics on the workpiece, okay, layer by layer, until it forms a single product. Okay, so those are the three kinds of 3D printing. First is SLS, second the SLA, and third is FDM. Okay, so now this is another process, plastic process, which is called injection molding. So plastic injection molding is the process of melting plastic pellets. So it can be a thermoset or thermoplastic polymers that, once malleable enough, are injected at pressure into a mold cavity, which fills and solidifies to produce the final product. Okay, so again, I will just send to you the video of this process so you can understand more about this process. So for the working principle, we have clamping. It open and closes the die either by toggle. So our quick acting can be quickly turned on and off. Okay, so it is about opening the passage for the plastic materials to be melted. Okay, hydraulic mold is directly opened and closed with a hydraulic cylinder or right, it is cylinder. Okay, so those two are can be used in clamping, which is about distributing the plastic materials to be melted. Second is injection. So pellets are fed by means of hopper into the machine and are moved towards the mold by injection unit. So the heat surrounding the barrel and the pressure melt the pellets. Okay, so the heat that is being imposed to the pellets melts the pellets. Okay, for it to be injected. Okay, cooling starts after it makes the interior mold. As the plastic cools, it hardens in the form of in the desired shape. So there should be a cooling process. Ejection done with ejection system. So meaning it will release the hardened plastics. So this is the schematic diagram. So this is the hopper feeder. These are the pelletized thermal or rather polymers. Okay, plastic materials. Okay, and once they go here in the barrel, they will be melted. Okay, by the heat imposed to this barrel. And once they are melted, they are being injected to the cavity or to the mold cavity here. And once it cools, it will be released. Okay. So next is another plastic process is plastic extrusion. Plastic extrusion is normally high volume manufacturing process where a polymer enriched with the desired additives is melted and formed in a continuous process. Okay, so plastic extrusion is about building, putting up melted plastic materials together to form a single product. Okay, by extruding the melted plastic materials. So first, mixing powdered polymer is mixed with various additives to improve the product quality and processability. Meaning the powdered polymers are mixed with other additives. Okay. Next, heating. Heater are set to required temperature according to the melting point, so that it can be the solution or the mixture can be extruded. So feeding, the mixture is gravity fed into the hopper and through the extruder throat. Okay, extruding, the materials flows into the annular space between the rotating screw and barrel and gradually melts. Okay, it is the same with injecting the melted plastics. Okay. Next is screening. As the melts approaches the end of the extruder, it passes through first through a screen pack to filter any foreign materials and protects the die plate from clogging. So here there is addition of screen. Next is molding. The melt is then forced out of the die to acquire the die shape and immediately cooled and pulled. So this is about shaping the melted metals in the mold, cooling and cutting. So this is the schematic diagram of plastic extrusion. So here in the hopper, the pellet plastic materials are being supplied, okay, and they are dried, they air dried. So there should be a blower here, and once they reach the extruder, they should be melted, and they should be molded here in the die. Okay, so next they go to the vacuum sizing chamber, meaning they are being molded or being shaped into more complex shape here. Okay, and water cooling bath. So here they are being cooled. Pull out assembly. So these are the conveyors, the assembly. Reheat station. So the plastic part should be reheat for it to be easily cut off. Okay. So next is injection. Another process of plastic materials is the injection blow molding. So it is the process of inflating a hot hollow thermoplastic reform or parison inside a closed mold. Okay. So this process is about blowing a heated plastic materials to gain the desired dimensions. So one example of this, one example of the product that is produced by this process is the cylindrical plastic materials, such as the mineral water bottles. Okay, so working principle, it is the combination processes. First is the molding of the preform. So meaning the plastic materials to be heated and to be blown is being molded first. Then the preform is reheated and placed in the blow mold, okay, for it to be blown and gain the desired shape and dimension. Air is introduced via the preform neck, and the preform is blown into the shape of the mold. So venting, so that all trapped air is removed from between the molding and the mold. Okay, the molding is then cooled through the cooling duct. Okay, so let's see the schematic diagram. So these are the plastic raw materials, and it will be heated here in the chamber, and it will be injected here in the mold. Once once the mold is formed, or the plastic material is molded here in the die, it will go to the injection molding section or station. Then it will be transferred here in the indexing shipper, meaning it will be attached here in the blow mold. Okay, then it will be blown by air here, so that it can it will gain its right dimension or desired shape. Okay, so these are the advantages and disadvantages of each process. First is SLS 3D printing. So what is the advantage of it? Strong layer adhesion, because it utilizes high laser beam, so it can melt completely the plastic materials. Has an excellent mechanical properties, because it will completely bond the plastic materials. Ease of batch printing, okay, because it is the machine or the 3D printer itself used in SLS is very large, that it can accommodate a batch of products or part to be processed. can be used wide range of variety of materials because it utilizes high laser beam, so it can melt a variety of materials, even hard ones. So disadvantage is it is very expensive because the 3D printer here in SLS is very large. High shrink rate because of strong laser beam, it produces high temperature. Unrecycled powdered materials because some powdered materials are being burned here, and long curing time. So it is because the part should undergo long cooling time because it is very hot. Then next, SLA 3D printing advantages. Batch production of multiple parts can be produced, so it also accommodate parts by batch. Parts possesses high strength and stiffness. Okay, so it is similar to the SLS. Good chemical resistance. So this is the difference of SLA to SLS. SLS process plastics have good mechanical properties, while SLA processes plastics with good chemical resistance. Complex parts with interior components can be built because the outcome here can be or can contain complex shapes or dimensions depending on what is programmed in your CAD system. Next is fastest additive manufacturing process. So this can be done by the computer system. That's why it is a fast process. Wide variety of materials can be used. So it is the same with SLS. This disadvantage: parts have porous surfaces because the parts here are being subjected to chemical solutions, and those chemical solutions makes the surface or structure of the plastic materials to have a porous surface, or those surfaces that have small dots. Okay, so next, FDM advantages: cost-effective, a quick method for producing physical models. Okay, because FDM is 3D printing is often used in automated or semi-automated processes, manufacturing processes. That's why it is a quick and cost-effective process. Disadvantage: limited due to the two parts having relative rough surface finish, okay, and lacking strength because the parts here are made in a fast manner, meaning they are not that hard compared to SLS and SLA, and their surface finish is not smooth, they are rough. Next, injection molding advantages: so high efficiency, enhanced strength, reduced waste, complex part design, flexibility, material, and color. So injection molding is used in semi-automatic manufacturing process also. That's why it has high efficiency, meaning there are many parts that are being produced for a short period of time. Disadvantages: initial cost is high because there are series of machines that is required to be used here in the setup of injection molding. Initial lead time are long because there are many preparations before the operation. Design changes are expensive. Okay, so in short, this process is expensive. Next, plastic extrusion process. So advantages: low production cost, high flexibility. So plastic extrusion process is the same with injection molding process because they are being used in semi-automated manufacturing process. That's why they have high efficiency. Okay, high production rate. When you say high production rate, it is synonymous to high efficiency. Okay, minimal wastage. Can produce product with varying thickness, colors. So it is the same with high flexibility. Then disadvantages: size variances due to unpredictable exact expansion. So there are shortcomings when it comes to controlling the expansion, thermal expansion of the materials here. Product limitations. So there are limited products that can be produced here. Injection blow molding advantages: fast production rate, low tool and die cost, ability to mold complex parts, high level of dimensional accuracy. So the main difference of this injection molding process with the other ones is it has high accuracy because of the use of nozzle. Okay. Disadvantages: limited to hollow parts, low strength, used materials are not recyclable, limited to thermoplastics. So this the advantages is it is limited to cylindrical products which have hollow parts, meaning the empty spaces inside. So those are the water containers and other containers, liquid containers. Next, LSS 3D printing, industrial applications, automotive design, aerospace. So you will see here in the application of SLS more on applications or products that are being subjected to high wear and tear, because the parts or plastic parts that is made here in SLS should resist high compression or other external forces. Okay. Then SLA, making of prototype products, investment casting patterns. So you will see here in the application of SLA that it is more in small applications, meaning it is not in the products here in SLA, or the applications here are not more of product or applications that require very hard materials. So the products here in SLA are softer than SLS 3D printing. Okay, because they can be used in the modeling or just prototyping of products. And the casting patterns. So we all know that casting patterns are being or expendable, meaning they are being destroyed in the process of casting. So it requires to be soft materials. Okay. Next, FDM 3D printing, prosthetics prototyping. So it is the same with SLS. Plastic project molding, or plastic injection molding rather. Wires, spools, packaging, bottle caps. So you will notice here that the application areas are more complex, okay, than the others. Plastic extrusion molding, pipes, tubing, wire insulations. So you will notice here the applications are more on wired, okay, wired plastic materials. So those plastic materials that are used in wiring. Next is injection blow molding. So water and soda bottles, shampoo bottles. You will notice here that the products here are containers or liquid containers. Okay. So thank you. If you have any questions, feel free to ask me. Thank you and God bless.